Yes. So we are solving problem number 11.28, right? Problem number 11.28. See, this was the graph what we have obtained, right? Very good. So again, let me repeat very quickly. We have plotted first what we have done. We have written all the wavelength. Then we have converted into frequency by C is equal to F lambda, F is equal to C by lambda, nu is equal to C by lambda. We have obtained frequency, and then we have tabulated our data, right? And we have plotted the graph of stopping potential versus frequency. Please plot carefully by taking, and please remember, as far as this numerical is concerned, if data is same, then please remember on x-axis you take only 1, 1, 1, 1, 1, 2, 3, 4 and so on, and here 0.2, 0.4 and so on, right? So plotting would little bit easy. These are the values which we have to take. Here the last data, frequency is less than threshold frequency, therefore no emission taking place, so no question of stopping potential. Therefore here for fifth data stopping potential is 0, right? Very good. So let me rub and let move forward. So our task is find out value of Planck's constant, right? Determine the value of Planck's constant, right? But so what we have done, we have given value of lambda 1, lambda 2, lambda 3, lambda 4, lambda 5, right? Then we have calculated C is equal to F lambda. So nu is equal to C by lambda. So we have calculated nu 1, nu 2, nu 3, nu 4 and nu 5. We have given the values of stopping potential, right? That is given. This is given. And just only we have calculated this much. Clear? This is our first understanding. Second, what we have done, we have plotted the graph of stopping potential versus frequency. We have obtained the various points, right? And then if I extend, then it meets at 5 into 10 raised to 14 hertz. So x-intercept gives threshold frequency, right? So our nu 0 is 5 into 10 raised to 14 hertz. Atlu clear? However, now look at our nu 5. It is 4.34 or 4.343 or whatsoever. So it is less than nu 0. Jo? Our fifth frequency 4 સુધી જુઓ 4 સુધી 5.4 છે 5.4. It is greater than nu 0. તો ત્યાં સુધી emission થશે આ બધાય માટે. Therefore we have obtained stopping potential. But here this is less than threshold frequency. For nu less than nu 0, no photoelectric emission takes place, and so there is no any question of stopping potential. Therefore it is 0. Atlu clear? Very good. So let's write from graph. It is clear that x-intercept is equal to 5 into 10 raised to 14 hertz, but x-intercept of stopping potential versus frequency graph gives threshold frequency, right? Therefore nu 0 is equal to 5 into 10 raised to 14 hertz. We can also verify that nu 5 is less than cutoff frequency, that is threshold frequency. So no photo emission takes place for nu 5 fifth frequency, and hence stopping potential is 0. Fifth frequency વખતે emission નહીં થાય એટલે stopping potential ની વાત આવતી નથી, right? So our threshold frequency is 5 into 10 raised to 14 hertz. Very good. Now We have told to determine the value of Planck's constant, the threshold frequency and work function. આપણે ત્રણ વસ્તુ ગોતવાની છે, Planck's constant, threshold frequency and work function. ચલો ભાઈ, now work function. Now work function. Work function phi 0 is equal to h nu 0. But for that we require h. Sorry, so first of all, let's calculate h. Right? We have obtained nu 0. Now, we know that slope of stopping potential versus frequency graph is h by e. આપણા ખબર છે, we know that EV0 is equal to h nu minus phi 0. Therefore, V0 is equal to h by e, nu minus phi 0 by e, right? So, comparing with y is equal to mx plus c. So, slope is h by e, right? So, therefore, slope is equal to h by e. But slope is equal to change in y coordinate upon change in x coordinate, right? This is y coordinate, this is x coordinate. Therefore, h, any one you can take. So, I have change in y coordinate, that is delta V0 upon delta nu. Therefore, h is equal to, chalo bhai, any damn stopping potential 1 2 1 3 કોઈ પણ આમાં લઈ શકો તમે, right? So let's take first and second, right? That is V01 minus V02. So here I have to write nu1 minus nu2, right? So therefore h is equal to, so h by e is equal to, chalo bhai, V01 is 1.28 minus 0.95. ગમે તે લઈ શકો, V01 minus V03 લઈ શકો, 2 ને 4 લઈ શકો, ગમે તે લઈ શકો, 1 ને 3 લઈ શકો, 1 ને ગમે તે લઈ શકાય, right? 1.28 minus 0.95 upon 8.219 minus 7.412 into 10 raised to 14, right? Very good. So 1.28 minus 0.95, so it is equal to 0.33, and upon 8.219 minus 7.412, so it is 0.807 into 10 raised to 14, right? Very good. ફરીથી એકવાર આપણે પેલો ગ્રાફ પ્લોટ કર્યો, અહીંયા કટ થયો, આપણે એને કીધું થ્રેશોલ્ડ ફ્રીક્વન્સી, એટલે પેલો એક આન્સર આવ્યો. હવે આપણે ગોતી રહ્યા છીએ h. તો આપણને ખબર છે સ્લોપ ઓફ ધીસ ગ્રાફ ઇઝ h by e, but slope is equal to 11th standard, lower standard, change in y coordinate upon change in x coordinate. So delta, so it is delta V0 upon delta nu. આપણી આગળ ઘણા બધા ડેટા છે, કોઈ બેનો ડિફરન્સ લઈ લઈએ, કોઈ બેનો ડિફરન્સ અહીંયા એ બસ મૂક્યો છે, રાઈટ? વેરી ગુડ. સો h is equal to, h by e is equal to 0.33 upon 0.807. 0.33 divided by 0.807. So it goes to be 0.4089. It goes up into 10 raised to minus 14. But I want to find out Planck's constant, right? Planck's constant. So make h as a subject. So therefore h is equal to 0.4089 into 10 raised to minus 14 into 1.6 into 10 raised to minus 19. So into, if I multiply by 1.6, then it is 0.654 into minus 19 minus 10 minus 29 minus 4, that is minus 33. So h is equal to 6.54 into 10 raised to minus 34 joule into second. Joule into second. H is equal to 6.54 into 10 raised to minus 34 joule into second. Write down up to this. It is very good. In textbook, answer of problem 11.28, H is 6.64 is given, right? 6.64, but we have obtained 6.54. In textbook, it is written 6.64, but we have obtained 6.54, right? Okay, now last, work function phi 0 is equal to h nu 0. Work function phi 0 is equal to h nu 0. It is 6.54 into 10 raised to minus 34, and our nu 0 is 5 into 10 raised to 14 hertz. Therefore phi 0 is equal to 6.54 into 5, so it is 32.7 into 10 raised to minus 20. So phi 0 is equal to 3.27 into 10 raised to minus 19 joule, right? Joule માંથી કાઈ પણ જોતું હોય divide by relation, so it is 3.27 into 10 raised to minus 19 upon it is 1.6 into 10 raised to minus 19, then it is in EV. So phi 0 is equal to 3.27 divided by 1.6, so it is 3.27 divided by 1.6, then it goes to be 2.04, so it is 2.04 EV, right? Very good. So this is what? Work function. Write down up to this. Now let me revise entire numerical again, right? See it, we have taken at least 40 minutes to calculate this sum. Chalo bhai, what was given? Lambda 1, lambda 2, lambda 3, lambda 4, lambda 5, right? This is first step. So step 1, calculate C is equal to F lambda, that is nu lambda. So nu is equal to C by lambda. So calculate nu 1, nu 2, right? Nu 3, nu 4, nu 5. We have given stopping potential V01, V02, V03, V04, V05. So we have obtained this data and we have tabulated, right? So now I have frequency and I have stopping potential. આપણે કશું જ નથી કર્યું, આપણે એક જ સ્ટેપ કર્યું છે. C is equal to F lambda, તો F is equal to C by lambda, F1 lambda 1, F2 lambda 2, F3 lambda 3, F4 lambda 4, F5 lambda 5. This is the first step. Clear? Second step, prepare a table. Third step, draw a graph, plot a graph. So we have plotted the graph and we have obtained graph like this. So x-intercept gives threshold frequency. We have obtained it is 5 into 10 raised to 14 hertz, right? This is stopping potential versus frequency graph. Fifth data, that is 4.343 something. It is less than threshold frequency, so no photoelectric emission takes place for this incident frequency. Therefore stopping potential is 0 because no question of obtaining stopping potential, right? Very good. Its slope is h by e. The slope is change in y coordinate upon change in of x coordinate, that is delta v0 upon delta nu. We have calculated this. Take any two observation from table and make h as a subject, so we have obtained h. So by this way we have obtained nu 0, then we have obtained h. Now work function phi 0 is equal to h nu 0. મારી આગળ 2 છે. It will be in terms of joule. Divide by 1.6, then it will be in terms of EV, right? So let me summarize the steps. right? Let me summarize the step. First step, we have given wavelength, right? Lambda 1, lambda 2, lambda 3, lambda 4, lambda 5. Then C is equal to nu lambda, nu is equal to C by lambda. Then calculate nu 1, nu 2, nu 3, nu 4 and nu 5. Then prepare table, right? Then step 4, plot graph of stopping potential versus frequency. You will get graph like this, and this will give you nu 0, that is threshold frequency, right? Then our first answer would be nu 0 is 5 into 10 raised to 14 hertz. Then next step, slope of graph is h by e. It is change in y coordinate upon change in x coordinate, that is delta nu. Then make h as a subject. Right? So it is delta V0 upon delta nu into E. You will get h. Then finally calculate phi 0 is equal to h nu 0 and convert it into EV by dividing 1.6 into 10 raised to minus 19 joule, right? So this is called flow chart. How I have remembered this, such a big numerical having, many calculation, right? So you can prepare by this, like this way, right? So I think while calculating slope, you take another data and you try to calculate h accordingly, but you will find just value nearby value you will find and try to find out the answer of phi 0, right? Thank you. Jai Mataji.